falls sick and she has to be hospitalized. So he was not able to make it today. So yeah, so we will have two speakers today. One is Gnana Sekaran and Manju. However, one of our volunteer, Vishnu, he said he would like to talk about K9S tool. So we will have a talk of 10 minutes from him as well on K9S tool, which is something good. So now I'll hand over to Alok to go with presentation. After presentation, Gnana will start his session. Okay, so sit tight, relax.
Okay. Thank you, Ritesh. So yeah, everyone comfortable now? Had your food? Food was good. Okay, thank you, Rakuten, for providing this space and food. It was really good. Okay, so starting with the first slide, um, as how many of you are new here, first time coming to this meetup? Okay. Oh, I see many here. That's nice. Thank you so much for joining. So we do this meetup every month. Okay. And we are now a community of more than 26,700 members. And we are growing on all different platforms as you're seeing in the screen. So definitely we'll be having the entire year we'll be having these sessions. So definitely you can see the upcoming events in the meetup.com. You can follow us here. You can scan the QR code if you want to follow, and then you'll get all the updates about the events that will be happening, not only in Singapore but all over the world. In the next slide, I'll share you where exactly in which countries we are already active. But then, if you want to get some details, you can follow. Okay. Okay, this is a QR code for sharing all the photos. You can take the photos and you can share yourself, or if you want to grab the photos later to share to your personal groups, then you can extract photos from here as well. And eventually, you'll get the slides from us in the same details. So if you can just scan this, it will be helpful for you. I'll wait another 20 seconds here. So we have multiple different global meetups from where as well you can see slides in this. Okay, let's go ahead. Okay, our mission definitely it is to make things stronger, keep strong for Kubernetes, and start fast learning, smart certifications, and definitely grow the community. Whosoever is interested for Kubernetes must come together, learn, share, and grow together. That's our mission. Okay. So these are sponsors for today's event. I want to. Sorry, are we good? Okay. Yeah, mute. Cool. Sorry, just a minute. Hello. Okay. Hmm. Is it good now? Looks okay. Okay. No problem. So much smiling. Mhm. Sorry? Yeah. Okay. Right? Yes, correct. Hello, hello, hello. Can right? Okay. Sorry for the break. Okay, yeah. Coming back to the slide, really sorry. So these are our main sponsors for today's event. Code Cloud is our sponsor, Packet and Rakuten. This uh, amazing office, Rakuten, and the food was offered by them. So thank you so much. And Packet, you can see the books there from Packet as well. And Code Cloud is our main sponsor. Okay, so meet our team. We have Yongkang, Fazir, and Ritesh. Ritesh is in front of you. So these are the main three members who started this particular community, and it is growing bigger. Hi, guys. Yeah. Okay, so our team is growing right now. So I'm Alok. You can see the first one. And we have Fatima, Kalyan, Jignesh, Shiva, and Anuj in our team. So, yes, this is our Singapore team. Globally, we have different teams as well. But yeah, for now, this one. So, this will be today's topic. First, Ganesh will be talking about the fully automated GitOps platform for K8S using Argo CD and Terraform. This will be very interesting to go through. As Ritesh said, we are unable to conduct the second one. Okay. But third will be Manju, who will be talking about the self-hosted Kubernetes. That will definitely be an interesting one for sure. And later, as ad hoc topic, we'll be introducing to you later. Okay. So these are the upcoming events that are globally will be happening. We have Australia, India, and then Philippines, Canada, UK, and Singapore as well. So these are the countries where we are active, and this will be the latest meetups. So if you have some colleagues or someone who is residing to these places, you can definitely refer. Or if you are traveling, you can join. Okay, so this is the Strong program or KubeNots program. This is a blue jacket. Those who are new, let me just tell you, there are 5 certifications in Kubernetes. Okay, so if you complete all the 5 certifications, you become KubeNots or KubeStrong. You get this blue jacket. Okay, that is a symbol of your excellence of completing all 5 certificates. That means you are the master in Kubernetes. Okay, the certificate details are already shown, which are the 5 certificates there: CKA, CKAD, CKS, KCNA, and KCSA. SAs are the security ones. Okay, so let's start with our first uh, topic today. I'll welcome Ganesh for the first topic. Yeah, thank you. Yeah, you can keep it. Okay, you need it. Okay, okay, you can keep it there.
Alok, sorry, can you stop sharing? Thank you. A moment. Okay, good evening all. So I am Gnanasegaran Gajendran. So I'm working principal reliability engineer here at Rakuten. So I'm having around 14 years of experience in IT. Okay, it's not going in screen. Just a minute. So today we'll be discussing, as mentioned in the first slide. So we're going to discuss how we can fully automate our GitOps platform using Argo CD. How many of them here is already using Argo CD? Okay, majority, right? So how many of them already automated fully without touching any UI? Oh, that's nice. Okay. So just what we'll be going to cover in next 30 minutes, right? So first we'll see what is GitOps, then we'll understand the key concept in Argo CD, then we'll have a small demo how we can set up this platform. So first of all, what is GitOps before we go to Argo CD? So GitOps is nothing but managing your application deployments with Git as a source of truth. So that is the main one to use GitOps. So why we have to use GitOps? So there are three advantages mainly. So where you can do versioning of your deployments, where you can easily audit since everything is committed into a Git. Then automation complete. And it will reduce the manual effort. So let's say, for example, if you're not having a GitOps platform, so we may face multiple troubles. Even I faced before using GitOps strategy, where you will deploy something else. You will expect this output, but when you deploy, your output is completely a different one. For example, you have a network policy, and this network policy you are aimed to application A, but there is a misconfiguration when you do copy paste and you misconfigured something. Then if you deploy your application, this network policy will affect some other application. So those kind of things, if you have tools like Argo CD, where you can easily diff your changes that you are going to deploy into Kubernetes. So definitely you can maintain the consistency across multiple environments. So there are multiple tools available for the GitOps. So mainly used tools are for the Kubernetes. One is the Argo CD, another one is the Flex CD. But still Argo CD is very popular because it's as UI and it's more user-friendly comparing to other tools. So I'm not going very deep into Argo CD, but we need to know the few concepts in Argo CD. The main things are project, application set, generators, and the sync policies. So project is nothing but controlling or maintaining your policies for your Argo CD applications. So when it comes to Argo CD application, so Argo CD application is nothing but maintaining or handling a set of Kubernetes resources. Example, your deployments, your stateful set. So just maintaining your Kubernetes resources for your actual application or the service. So this is called application in Argo CD. So then what is the application set? So application set is nothing but to maintain your Argo CD application itself. And inside the application set, we have two things. Mainly we have two things. One is the generators and the sync policies. So we'll see this in a live demo. There are so many generators available. Let's say, for example, instead of you keep writing multiple YAML file, the list generators will simplify your, or it will eliminate your maintaining multiple YAML files. So they are widely used, but mainly I also used the list generators and the cluster generators. For example, when we use this kind of a use case, let's say, for example, you want to deploy your application or a component into multiple namespaces. So instead of you write multiple Kubernetes resources file, so you can keep your Kubernetes resource file in a single phase, and you can use list generators to deploy into multiple namespaces or into multiple clusters also. Let's say, for example, the cluster generator. Let's say, for example, in your Argo CD, you have a control of 10 Kubernetes cluster. You want to deploy a particular component into all the 10 clusters. So in an easy way, you can use a cluster generator. It can deploy all your clusters. Example, let's say, for example, anyone will deploy Prometheus, right? So Prometheus, definitely you have to monitor your Kubernetes cluster, then you have to deploy this Prometheus into all the Kubernetes. There are cases where we have to deploy the same component into multiple clusters. By the time you can use the cluster generator. So like this, we have so many generators. So this is the widely used two generators. Then we have a sync policies. So how we want to, we mentioned the Git is the source of truth, right? Let's say, so how we want to fetch this changes to your Argo CD applications. So one is the manual way. You can take a full control and you can monitor, and you can, let's say, for example, few team will think that for production deployment, the automated sync can cause trouble. So some team may take a decision, it's better to have it in a manual sync. There is an automated sync where it will be keep polling the Git changes. So whenever the changes is happening to the Git, then it will automatically, it will sync. So these are the main concepts in the Argo CD. Now, this is our main topic today, right? So we about to set up the GitOps platform. So as you see here, by seeing this diagram, you can easily guess what things I'm going to use. So I'm going to use the Terraform. So this inside the Terraform, we're going to use a Helm. This Helm is going to deploy our Argo CD. From this Argo CD, you can able to control multiple clusters, but today just we're going to see deploying one simple application. So, and this Argo CD will get resources from Git, and then it's going to deploy in our Kubernetes cluster. So now we understand what is needed, right? Now, then so these are the steps. So first we're going to see some sample code of the Terraform. I'm going to show my demo in my local itself. It means that there is a local Kubernetes cluster is already running. So we are not going to do that today. But I will give you end of the demo how we can integrate automatically deploying your Kubernetes cluster, as well as how we can do without any manual intervention also. Then we're going to, as I mentioned, we're going to use Helm to deploy our Argo CD. Then we have a concept called apps of apps. So the Argo CD app will deploy another set of Argo CD apps. So that we call in apps of apps concept also we're going to see today. And then finally, we're going to deploy a simple Spring Boot application and then say hello. Okay. We mentioned, right? So we're gonna use 3 components. One is the Kubernetes, another one is the Helm chart, and another one is the Argo CD. So if you are coming from Terraform background, so you know, so it means that for this 3 component, we have to save the providers. Now we mentioned the what providers we are going to use. Now for that provider, we have to give the configuration. Configuration in the sense, we can say like for authentication. We simply going to use the local cluster. That's why I simply given my Kubernetes context path here and what is the context name. And when it comes to Argo CD, we'll come to this part later. So let's say, for example, now you deployed Argo CD. After you deploying Argo CD, you have to authenticate to Argo CD itself to deploy or create configurations inside your Argo CD. For example, you have to say, where is my Git repository? So in Argo CD, this is called repositories. So we'll show those configurations later after the demo. So for this, let's see, you are dynamically getting your password. The same way you can get your address also. But here I'm just hard coded, but still it is, you can get it easily dynamically. So these are the things. Now we'll go to the demo part. So in Argo CD, we done the provider settings. Now, what we have to do, we have to deploy Argo CD using Helm chart. So I'm doing the same here. If you see, there is a Helm release. Inside the Helm release, I'm just deploying Argo CD using, there are some configurations I gave here, that part will come later. And then this is the part I mentioned. So you have to do authentication for your Argo CD to do further configuration because it is a fully automated, right? So for that, you are reading your Argo CD secrets through this. Okay. Then we have as I mentioned, this is the repository we have to configure to deploy Argo CD application. So there are 2 things. First, we're going to deploy Argo CD application. From Argo CD application, we're going to deploy our demo application. So for this, I'm just configuring where is my Git, the Kubernetes manifesto simply. And as we mentioned, we going to use apps of apps concept. For this, we have to deploy one more component called Argo CD apps. So that's it on the Terraform side. So now we'll go into we run this code. Later, I will show you what it is doing. We'll go through this one later. I just clean up everything. to ensure. So we can see here, I'm connected to my local cluster. Inside this local cluster, you can see this is just namespaces, which belongs to the Kubernetes itself. So now after the demo script we run, so we should have another 2 more namespaces, one for the Argo CD, another one for my demo application. So let me run this demo. So it is just showing the resources it's going to deploy. Okay, it will take, might be another 60 seconds to deploy. Meanwhile, I will show the shell script what we have here. For example, in the demo.sh, I just connected to local cluster and simply, okay, I simply, yeah, I'm just searching for that. I missed somewhere. Okay, sorry. Okay, I have here. I just do simply Terraform apply. And then I'm just displaying where I just exported Argo CD into this hard-coded node port. And then I'm just displaying the default credential to log in. As I mentioned, we have to do small step to deploy my application. I will show you shortly. So you can see this is the URL I got, and this is the password I got. So simply, we'll click this. We have admin, and this is my password. Just log in. So this will apply automatically, but it will take some time. But for time being, what I will do, I simply do sync. See, now it is synced. This is the, if you see, this is the demo app. This demo app, nothing but it is the Argo CD application. This Argo CD application is deploying my actual service that is called application A. So if I click my application A, so you can see it is deployed some set of deployment and then service file. So we can see here. Yes, correct. Yes, correct. So as we seen earlier, we mentioned here, right? So when we see this code, we have mentioned, okay, I might have gone through this. Okay. This is the apps of apps we mentioned. So here we mentioned in this Git repository, just deploy my Argo CD application. This is the parent app, we can say. From this parent app, we deploy the child app. So we'll go to in-depth later, but for now, we'll continue with the demo. So my application got deployed, and we can say it is the simple greeting message from my service. This is just an example. So if I want to end, that's all. So you can see it deployed one more namespace. This is the Argo CD where our stuffs are deployed. If you see, so this many components is got deployed in between this time. And This is the demo app, and it is displayed. We can see this is the service, and this one also we exposed as the node port service, and it is running locally. I will go to the Git repository. You can understand more clearly. So if you see part of this Terraform code, what we are doing here, we are doing Argo CD apps deployment, right? In this Argo CD apps deployment, I'm using this values.yml file. Inside this values.yml file, if you take a look, so I mentioned that this is the Git repository to look for the parent Argo CD application. So if I go to here, so I mentioned this path, apps environments dev. So if you see here, this is the same thing, apps environment dev. So under this, I have this customization file. Inside this customization file, you can see that it is the reference to my actual application -a. So this application -a, it's nothing but still it is the Argo CD application. So if you go to this Argo CD application, inside this Argo CD application, what I'm saying again, so there is a path is different here. So I'm saying you go inside a application -a and apply to this cluster. So same thing, if I go to dev application A, and then I'm simply deploying a simple hello world VC, and the service file, I'm just exposed as the node port. It is just one example for deploying, but by using this apps concept, so you can have multiple projects. In one project, you can have multiple applications, and all things you can control easily through this way. So I will give just a pass. This is everyone okay? Is that able to understand what we are doing here?
Can you configure the repository for the Argo CD itself, and where do you configure the repository for the app?
Okay, so it's a good question. So I also forgot to show that. As I mentioned here, so we're calling this resource in the Argo CD. In this Argo CD, we can see that there is a module called Argo CD repository. Inside this Argo CD repository, I given the URL. But you can completely have a proper automation, but currently it is a public. That's why I'm not using any authentication for this repo, but you should have something like SSH key or something that should come from your Terraform variable. So for now, it is a public repository. I just gave the URL alone. So with this module, what this Argo CD, the Terraform will do, if you go to settings, if you go to repositories, then you can see this repository is added automatically. So we are adding this repository part of your Terraform code itself. Is that clear now?
But this one actually has the CRPs for the Argo CD.
Yes, correct. No. So Argo CD will be, the CRDs will be deployed part of your Helm chart. So we are using Helm release. This Helm release will deploy CRDs of. Yeah. So this Helm chart, if you go to that Helm chart, then you can easily so here we can see Argo CD related CRDs. And this is the, or still one more thing. So this is the Argo CD. Okay, to call your Argo CD, I mean, you are creating a repository inside the Argo CD, right? It means that the provider you are using should able to authenticate to your Argo CD itself. Then only the Terraform can call your Argo CD, then it can create repositories or any cluster addition. This thing. This is the one, if you remember initially. So for the Argo CD provider, we are using this password. As I mentioned, currently it is public, so I'm not doing any authentication. But simply, if you are having proper pipeline, you can use, let's say, for example, if you are using GitHub Actions, in the GitHub Actions, you can use GitHub Actions variable. And from there, you can inject easily. So you want to go to the Argo CD, right? Okay. So if you take here, mainly we are deploying two things. One, you are deploying your Argo CD using Helm chart. So now you deployed your Argo CD. Now Argo CD is up and running. Once Argo CD is up and running, this Helm chart is will deploy including CRD. So it will deploy your Argo CD, including all the components, including CRD. You deployed your Argo CD, then next part, once you deploy your Argo CD, the another part, you have to configure the repository where you can read for your Argo CD applications. So for this only, we are configuring Argo CD repository. And this is the nothing but we are using apps of apps concept. So we are deploying Argo CD apps also. So the apps of apps, nothing but you can see here, I have to create Argo CD application, right? Then only it can deploy my Kubernetes resources. If you remember this slide, so what we seen here, it's not good. Okay. So here, right, the Argo CD application is nothing but it's a set of Kubernetes resources. So to deploy your Argo CD application, you need another application that is called apps of apps. So for the apps of apps only, we are using this one here. We can say this is the parent application. This parent application will deploy your actual application later. So inside this parent application only, we mentioned this is the project and you look for, I mentioned this past Kubernetes demo app. So here I have the parent app. From this parent app, we deploy our actual app. So if you search on the internet, Argo CD apps of apps, there are a lot of examples. You can easily work it out. Yeah. And currently it is in a private mode. Definitely I will make this as the public. My plan is to, as I mentioned, it is the fully GitOps platform, right? So my aim is to deploy GKE and it should automatically configure all these things. So definitely I will ensure that this will be publicly available and including GKE deployment and the complete automation. And it's already, this one also, it's a public only. You can, you can catch me easily on this repos.
So this one is only taking care of the CD part, right?
CI part is not here.
Yeah, CI part not here. No, he is asking for building the application itself, right? So now we are taking after the build got completed, we assume that. So currently it is just for demo purpose. It is everything is hard coded here. This demo app simply getting this image from Docker Hub.
Yeah. Basically, your image has to be readily available. Then
Yeah, correct.
there's something called Argo workflow on the build image, right? So what happens is because Argo workflow, there is a comprehensive, it's a completely CI pipeline. So you can build, you can trigger from a webhook, deliver it, you can route to Canico, you can develop your image, and basically you can upload that entire thing into this. You will create a version there. And Argo CD will pick up that because you updated it as your code. So that's why it is completely automated as this image. Right? So if you use Argo workflow, or there's something called Tecton pipelines, you can utilize that to do complete CI. So those with any of the deployment, there's Argo CD, the competitor to this, right? You can utilize that. So you utilize the CI pipeline, then this is a CD pipeline.
So it means to identify which image to deploy. So when the application builds the Docker image, your YAML file should find to the latest image, which is so that the Argo workflow solves it.
Yes. So there's two ways. Right? When you build a workflow, Argo workflow, the final image that you generate, you load it into a registry, right? And then you update this YAML file, the deployment YAML file that I have. You update that in the GitOps, right? So moment GitOps is updated, Argo CD will pick it up, and it will pick up the new version of it, and image version of that will all be
The latest image will
the image that you upload.
Normally, how people do it, once they build the image, they push to Chicago or somewhere. Argo CD has a plugin to automatically fetch it from there.
The idea is that if your CI pipeline is something else and you're just updating the image, yes, you can do that. But if you're building the entire end-to-end cycle from workflow to this, people don't even want to build up the workflow, right? Or Argo CD can be run, Argo workflow can be run just by, you can invoke a REST API and everything will start. We can have a section on Argo workflow sometime.
Okay.
No, it can be based on the Git commit itself. Sorry? It can be based on the Git commit. The trigger can be just based on the Git commit. It can be anything. There are various Argo workflows so powerful that you can fire it from your mobile. You just click on it and do that. We do that in some of the organizations that we consult. The idea is that you have somebody has an access to it. It's an authenticated one, and it says, okay, I have checked in all the code and all that. You just click a button out, the entire Argo workflow runs. We build it through Canico. Canico is the container image builder, right? You use to Canico builder up. You generate the deployment file, you generate the image, and Argo CD is waiting for it, and you see the cycle, right? They keep on syncing up. I think you show that they're syncing of it.
Yes, correct.
Yeah, so you can keep the syncing always on, or you can keep it on demand. Does it have like integration with different approvals? Let's say come the service now. Does it integrate with them? The idea is that it's upon what you really request. Yeah, I think we need more. But I think we can have a separate workflow. The Argo workflow or Tecton pipeline can go.
Yeah. But to be honest, I work for Argo workflow, but I would say it's more complex, I would say, for the simple deployments, because to just simply run a Gradle command, it has to write a lot of YAML file on the workflow. And if you have, let's say, if you're managing a big team with multiple microservices, I would say it's really very, very complex if you're choosing Argo workflow. It might be works for if you are deploying 1 or 2 microservices, but for larger organization, it's definitely more complex. So initially we started with, when I was joining Rakuten, they're using Workflow, but from Argo Workflow, I completely migrated to GitHub Actions. It's really complex. But thanks for highlighting that. Yeah. Yes, correct. Okay. Mostly, I think I'm done from my end. Yeah. Is there any other questions to discuss?
How do we configure Argo CD in the high availability? understood that it's a stateless. Most of the time, states are maintained into the each clusters XCD database. But if I want to have a higher availability, how do I do that?
So the backend is actually it is keeping everything in Redis. So no, it keeps for including this configuration everything in Redis only. So majority your configurations are in, let's say for example, it will be in your. Let me confirm 1 second.
Layer, it will have a TTL, like how whatever you define, it can't be permanent, right? I mean, because a caching layer.
I forgot actually, but there is an easy way because this UI itself might be the backend could be MySQL or something else, but definitely HA is easily achievable only.
The primary objective of Argo CD is to compare the state from your CI, and let's say somebody manually makes some changes into your deployment, then the pipeline should trigger and reinforce.
Yes, correct.
So that is the actual use case of it, right?
Yes, correct. Let's say, for example, you deployed your application and then somebody manipulated in the backend manually. Let's say they modified your network policy or even they changed the version in the backend who has. So the kubectl, it's almost like a root access, right? So they can modify easily on the backend, but you will never know what modified, who modified. But if you have a tool like Argo CD, it can easily show here the moment it's going out of sync, then based on the Git, it will easily send the alert that it is out of sync. So you can easily know if something, the backend is not in the desired state.
Or even Redis also, the Argo CD element values, you can make it as Redis HTML. At least one regard one can serve by the other automatically. Yeah, so the separate component of controllers and all those things. Yes. Yeah, you can run them as a replicas or the yeah. Oh, yeah. Just one more question. Have you ever faced challenges like you have enforced some policies using OPA, and then some of the settings of those Kubernetes clusters are enforced through OPA, but are not through CI, and Argo wants to override, OPA wants to override like a false positive conflict. Have you ever encountered this kind of a challenges?
No.
One is declarative, one is like through CI, whatever changes you.
Yes, this will happen sometimes, right? But it's really difficult, I would say, because what will happen? Your CRD is trying to control something, and you have Argo CD committed with something, but it will go something like a infinite things. So either you have to modify your configurations on the CRD side, which you applied, or you have to modify accordingly on the Git. But the things will happen like that. So yeah, carry on, please. Okay. Is it clear for you? Okay, I think if any other questions? Okay. Okay, then thank you all. I'm done. Yeah.
Thank you. Thank you again, Sankaran. Next, we invite Manju for self-hosted Kubernetes. Manju, thank you.
Hey, hi all. Manju here, and I do a lot of consultation with all small companies, also with big companies and all that. So one of the key interests when I started Kubernetes quite some time back is how do we get started off, right? And a lot of times, okay, do I need to give Google Cloud or Azure Cloud and all that, and find it difficult to log in, give credit card details out, and when you get this Kubernetes there, it's always a managed Kubernetes, and that's what we're going to talk about. What is self-hosted and this one. So I found self-hosting is quite simple out. It can be a laptop, or you can get into a cloud and get your own instance and just deploy a small single node cluster, right? And that makes you most learning out this. So that's what we're going to start off on. Okay, some part I think we need to move across. Okay, it's visible, right? Yeah. So let's look at what is the K8S architecture. Why is, okay, entire screen. I don't know why there's a gap there. I need to use this. How do I take it out? Okay. I think should go away. Okay, that's okay. So what I want to talk about is what is Kubernetes architecture. When you dig down deep into it, we always work on the worker node and all that, and we forget the larger picture of it. So what I wanted to just keep a snapshot of what is Kubernetes architecture all about. A quick this thing. On a high level view, there's a control plane and there's a data plane, right? This is the common of a Kubernetes structure, right? You have a developer who logs in, or any GitOps guy who logs into the cluster using the API, this thing there, and manages the entire cluster, whereas the end users can be any applications or can be different people who actually use the application. They actually do not even know about the cluster being existing. They get their application URL and they start working towards it. So this is the entire structure of it, right? And people think that, yes, I need to have, when we talk about Kubernetes, people think it a very complex way. This is a very complex looking diagram, but look at it, it's very simple. There's a control plane, there's a data plane out. And most of the people think that, okay, I should have a node for that. And that's what is like in a master node and a worker node and all that. But technically, if you look at it, now I'm talking in terms of self-hosting Kubernetes, everything can be a single node. You don't need all this node. And you can work, when you want to get started on, this can be a single node and make it very simple. So Kubernetes, people think it is very complex out, but you look at this complex way, you will feel it is complex. But make it very simple. It can be a single node cluster with both control plane and data plane together, and single node, you deploy everything out. And that's what we let them to do, something there, right? So this is what I was trying to say. So that's a difference between your self-hosted cluster, self-managed cluster, or a managed and a self-hosted cluster, right? So in managed clusters, you don't have access to control plane. Your AKS, GKE, or whatever managed clusters, even the smaller, if you have a DigitalOcean or if you have Linode one, they have their own Kubernetes cluster, managed cluster. You don't have an access to the control plane, and you only see the data plane. So what happens is, as a part of learning, you don't interact too much with the control plane itself. We don't know how to really manage the HCD, the different API servers, how it's gonna, and how do you do a HA of that, right? With self-hosted, this is what you can do about it, right? So this is where I believe that the self-hosted cluster should be here, right? So a quick point on, you install all the components on your own. So in the self-hosting, you control your own, you manage your own control plane. It can be deployed in your own infrastructure, or you typically have non-control, non-critical system. So self-hosted one, it's not just for your learning. It can also hosted in production. People use their own data center. They host a self-hosted cluster. They don't go to GCP and all that, and they do that. And typically non-critical systems out, you can have the data plane and this thing combined. Yeah. And these are the typical distros that you see, right? There's Minikube, Kind, and K3D. So how many people are using a self-hosted one? Can I see a hand? Okay, quite some. And do you use any three of them? Sorry? Yeah, local development need to use that, right? Okay, but my point is that when you use this Minikube, it's not exactly because everything is Docker. So everything Minikube is a Docker and Kind is a Docker and all that. And my point is that let's not talk about it because there are better Kubernetes one, and that's what I'm going to show. It's called micro K8S, K3S, or K0S. Those are production grade. You can deploy it into the environment. So that's what I'm going to show Minikube. I'm going to show you micro K8S and K3S and K0S, and hopefully we can get also talking between them, right? So because they are all Docker based out, they typically don't give you the real multi-node cluster feel, right? And Minikube, you cannot do multi-node. You can do multi-node, but it is more of when you deploy a multi-node cluster within Minikube, it's a Docker container, and you have a multiple nodes acting like a container. So it's a container acting as a node, right? So it's not really an actual node. So your Docker is, because Docker is essentially only single host. So that's a limitation of it. So I encourage that we will use that micro K8s, K3s, and I'll show that out. But why self-host, right? That's the first thing that we need to talk about. The first thing that I was talking about, simulate a production-like environment, right? So most people think that Kubernetes means that, as I said, control plane separate and data plane separate and all that. But the idea is that, and I've convinced a lot of organizations also to make sure that the cloud has become expensive. The cloud has become very expensive nowadays when you deploy it, and a lot of people are not declouding themselves. So, but they cannot decloud because production is quite important. Expanding your scenarios or expanding your business is easier in production, and that's okay. So you don't need to decloud a production out. But your development, your SIT, and maybe even UAT, right, based on whatever your business criticality feature is, you can actually do all this thing out. And there are organizations who do the development SIT in completely local hosted environment out. And with this GitOps feature, right, all you have to do is that whenever you have developed everything out, and we talked about Argo Flow and Argo CD earlier, right, all we need to do is get your images put into a registry, and then you put your GitOps and put your deployment files, all the YAML file that is changed into this thing, and Argo CD will take care of it, or Flux can take care of it. So that's why, and this becomes very fast because you have access to it and you control your cost. So CTOs like it when you talk about it. 5 years down the line, 3 years down earlier, it was always about, okay, let's move everything to cloud because I don't want to own an extra checker. People are coming back on this thing. So second point is we just touch base upon is that there'll be a consistent DevOps. If you use Minikube and all that for local development, and when they shift to a production-like environment, some of the testing cycles, because to multi-node on, you cannot really replicate the networking part of it, right? You don't really use CNI. CNI is a container network interface. You don't really use that. So by doing this kind of production-like setup that you have in a local environment, you can simulate this production. So when you deploy to actual production, you have a almost similar one, right? So that's one. And we talked about cost, right? So when you also have SIT development and all that, you keep on auto-scaling out and it goes out of structure out. What we also, and I will talk more about it. And in fact, we'll talk about each of the different items. This is the simple thing about what we can do about, how we can do about it, right? So on the right-hand side, you see production. A typical production, I've just shown multiple pods to it. There's a front end, there's a back end, and there's a CNPG is, okay, I can't avoid this. Okay, so CNPG is a database out, a cloud native Postgres, right? So this is your typical setup that you have out. And in development, you should have the same setup out. The only point difference is you have 3 replicas here, probably you're working with 1 replica, right? So idea is that you probably cannot, when you want to do a performance testing, you probably cannot do that there. And that should have so when you talk about productionized system, we want to do a performance testing or a scaling testing and all that. Yes, you need to have your actual cloud because they can auto scale and much more cheaper. But if you're developing, you develop exactly like this, and that's what we have. And all your Terraform, Ansible, and all that can be deployed there. And the moment everything is there, your GitOps will take care of it. And this is a typical way to do that. You have dev branch, your trunk range. So when you have dev branch, when you commit out and you merge into the main branch or a trunk release, then your Argo CD will pick it up, right? Same thing, idea is that, and I want to talk about Velero and ST endpoint, why this is very important. Typically, what we've seen, there's some organization very receptive about controlling the cost. And you know what is costing more? In the cloud that you see, so you can have this compute instance. You don't take, so let's say you have one GCP or take a compute instance, you can deploy Kubernetes there. But the idea is that when you go out 6 p.m., you end this thing out. By the time you come to 9 a.m. tomorrow, you still have your instances running in cloud. And instances, unless you destroy the instances, its cost is not going to go away. So with this local kind of development, you can avoid that. Or you have this Velero kind of setup out. Every 6 p.m. or whenever, let's say a development team who's ending the day out, they just trigger a workflow where everything gets backed up in Velero. Velero is a backup theory. You also have wall sync and all that. You back up to S3. So, and then tomorrow morning, let's say you start at 9 a.m. At 8 a.m., it will automatically trigger this and reestablish everything out. So you save that time. So remember 744 hours. 744 hours is a typical calculation time that you have for when you book up instance. The entire month take about 744 hours, right? With this, because you're cutting about this thing, we calculated it only about 400 or 500 this thing out. You're saying 200 hours. So now over the scale of it, and when you multiply the teams, you save the cost. So that's the beauty of this thing. And people, because you practice this here, you're backing up this thing, your backup in production is exactly the same. There's no difference, right? It's just that you do much more things in production because you have this ST endpoint out, then you have a multiple endpoints out so that it's a 3-to-1 backup policy, right? So that's the difference between, but exactly what you do in production, you exactly do it in development as well. Same for CNPG, you can have a less number of database here. So CNPG is a cloud. How many are using CNPG? Okay, so CNPG is, have you used Postgres? Okay, so Postgres is, CNPG is a cloud native version of Postgres. Typically, you don't deploy databases on Kubernetes, but CNPG is an exception. There's something called CockroachDB, which is also very good. So it's a distributed database out, and you can test it out. Very stable. All you require is the Helm this thing command to deploy it.
How does this compare with the
Cube? Okay, so, and that's what the point is, that you don't, in the development kind of one, you don't have this autoscaler and non-scaler because then you need some other elements of it, right? So
typically what we do is
that can be done as well. Yeah, it's the same thing that we can approach it. Yeah, there are sometimes, so I'm not used scoop down scaler too very much. The idea a lot about is you don't need that additional tools. You can just use Velero to store it, and you can replace, because everything in S3 backpoint, the entire thing, including Velero, can be backed up. That's only the beauty of it.
Yeah, using Velero for not for this
My point is something like that. Why do you have to have a different setup in a development than production? That's my whole concept about this thing out. Whatever exactly that you do in production, that should be replicated in development. So you don't have to change anything out. That's a thing. Can you use a different tool? Of course, you can use all the tool out. The whole perspective is that if you have something going wrong in development, going on in production, it should be replicated out. It can be because of your bad manifest files, because you forgot to change some tag which are supposed to go in production, supposed to go in development out. With this kind of setup, you have exactly the same setup, right? So that's what we try to do that. Obviously, there'll be some differences. This is what I was talking about, is that the controlling costs, right? Not everything needs to go into your cloud system out. So your staging and performing system and production cluster, obviously you need this thing out because autoscaler works best in cloud. That is more efficient. You can actually downscale, you can actually upscale and all that, and you require that, right? The HPA scaler that we talked about. But and UAT, you can argue upon it. If the user base is quite huge, you want to replicate the clusters out, replicate more of data there. Yeah, fine, right? But development and a SID cluster, I believe that it can be done on your local environment out, or you have a very low cost. It can be any environment, right? And people know only about 3 major cloud providers, right? And all organizations follow that. It's GCP, Azure, or others, right? But you know about Linode and DigitalOcean and their Hetzner and all that, they offer a very low one, and they're very competitive. They're reaching to organizations out saying that it's very cheap for them to use that thing. Why not use it? Because the only thing that is connecting is all you require is a GitOps, right? And once you have a GitOps, moving from your development to production becomes very easy. There was a time earlier where people did not want to move from cloud because when you have other environment out, then you have, if you have need to deploy rapidly, then you have some problems about how do you want to connect about it and all that. But right now with GitOps, everything is there. That's what Kubernetes is quite useful for. So this is how you can control your cost. This cost should become as low as possible, right? Yeah, let's go. There's not much. And finally, right, at the end of it, it's all about the tremendous learning ability. If you have a self-force, you control a lot of stuff. And what are the typical things that you control, right? This is what I want to go look about it, right? A lot of people forget. A lot of people look at the first diagram that I've shown you, the control plane and the thing out. But what people don't talk about and don't change very often, if you're not self-hosting and cloud and all that, in managed cluster, even though you can change it, but not many times you change it. Or some people don't even allow. So these are the different layers, like your data source, etcd, your CNI, container network interface, the storage interface out, CRE or runtime interfaces out, your ingress and service mesh. This is service mesh, arguably people use it, not use it, but nowadays it's becoming quite common when you have multiple clusters, you rather use a service mesh, right? But what is more requirements? You know that if it's self-hosting, you can change in each layer of it, right? So let's go a bit of it, right? Data store is the etcd, which stores the status of all the state of all the resources and the thing. CNI is your container network interface out. It can be more than one CNI. People don't use that. If you've heard of something called Multus, it can you can have multiple interfaces on that. So each pod can have a multiple interfaces, right? Your storage interfaces, there are three major points of it. We'll look in the next slide. Container runtime, this is the basics of any container pods that need to run it. Ingress gateway, you have an entry point. That's an entry point for all the cluster and always routing the traffic. Service mesh provide a security, observability, and advanced routing. Actually, we have done this thing. If you're more interested in service mesh, I think we have a video there where I talked about the entire thing about service mesh, how can really connect it, all the three different interfaces that we have. And obviously the kube DNS or a core DNS that we talk about. So the next slide talks about the same thing, just at different products which is there. So etcd, you can actually change it. The typical usage in different one is SQLite, SQLite, and the traditional databases. SQLite, people don't, it's an embedded database, right? Or even SQLite is an embedded database, but slightly much better of it. So you can change that, right? And but to really establish what cloud use, they actually use the traditional databases. You can actually use CNPG, have a cluster running CNPG, and have your entire all different clusters backed up using this thing. Your CRI is container ID and CRO, the thing. CNI, the Flannel, Calico, and Cilium. These are the more important ones. There are more of it, but then these are the important ones. I suggest not to use Flannel because Flannel is very, very basic. It doesn't have a basic network policy. What I mean by network policy is that let's say I have two namespaces, right? Pods and two namespaces out. If you want to make sure that, okay, let's say I have three namespaces out, namespace 1 needs to talk to namespace 2, but namespace 1 should not talk to namespace 3, right? If you want to do that, you can't do that in Flannel. You can write different rules, right? But from the network policy layer, so network policy layer works on the OSI layer, the level 3, right? So at that layer, you can control it, right? And that's why Calico is much more useful, Calico and Cilium. And Cilium is, Calico is also coming with this thing. I mean, it's already there. It's called eBPF. But eBPF is ingrained built in Cilium. eBPF, anybody knows about eBPF? Yeah, so just for this thing, right? eBPF is something like you control at the Linux kernel level. It's like writing a kernel level programming out. So Cilium works on that particular layer. So when you're utilizing it, the efficiency, the network transfer, it becomes very less out. So Calico earlier was not this thing. Now, I think past 2 years back and all that, they have completely eBPF. A CSI, this local path comes always for almost all this thing out. And utilize that. If you're working on a single node cluster, use local path. You don't need to use anything else, right? If you have a distributed, if you have multiple nodes, right, where you have a distributed services out, these are the main important one: Longhorn, OpenEBS, and RookSafe, right? Longhorn is beautiful. I like it because a nice UI out. You can control it. You can show this thing out, and people can manage about it. There's also a very good API. RookSafe is very good, but it's very complicated. OpenZWay is sometimes in the middle out. So this is how it is. Long and very easy, but sometimes people say it's a problem out, but it's a very good backup with the backup policy. Entire thing can be backed up to S3 endpoint. CodeDNS, we'll not talk about too much about it. And this is a typical one is traffic and caddy. I like traffic very much, but this thing. People use NGX, I don't like it very much. But traffic is beautiful because it's one of those MIT license. You can change anything out. And so there's absolutely no licensing problem, unless you go for an enterprise version of it, obviously. And finally, is Cilium mesh. There are three important ones, four important ones. Cilium that you see is slightly different from the Istio, Linkerd, and Kuma. So what happens, the way service mesh works is that there are pods and there is a sidecar which controls all the traffic, right? So that's how service mesh works. It controls all this thing out. But with Cilium, it's a sidecar less. It works at the network layer itself, in the node level, right? So that's why it makes Cilium much better. Istio is coming with something called ambient mesh, which is also similar to what Cilium is providing out, but it's still in experimental phases. You cannot go to production with that, or they will not own. If they find an issue, they will not own about it. So Istio is coming to it, but this is a feature change that's happening in service mesh. They're moving from sidecar 1 to sidecar less. Okay, how much time do we have? Okay. I'll see if I can do the demo then. Yeah. So this is the things that these are distros that we talk about. So don't use Minikube, this thing and all that. These are the one. Micro K8S by Canonical, K3S by SUSE originally. SUSE recently bought it, but K3 was originally from Rancher. And K0S was Mirantes. People don't like Mirantes very much, but you heard about Lens, IDE. That's why Mirantes. So they are the same people. But KS is very lightweight one. And finally one, if you're really have tested all that, try Talos only when you have kind of mastery all this. Talos is something very different. Talos itself is a Linux operating system, which is custom made for Kubernetes, right? And it's beautiful. You can look for it, and they have a lot of videos on this thing out how do you want to look for it. So I would suggest if you're more into Ubuntu, use MicroK8S. If you're not into Ubuntu and Arch Linux and all that, try K3S or K0S, right? And these are the default that comes on. So MicroK8 almost have a good default out. You can go to production. They claim that they can go to production at it. K3S with default, you should not go to production at because Flannel is not very good. And data store is still SQLite, which is very bad. So you have to change it to either a CLMS Calico, and data store, you better change it to a traditional database. It's very easy to do that, okay? And CSI local path, or you can change anything else. But what I'm saying is by default, you should not go K3S default with production. You need to make a changes of it, right? K0S is, again, very, very simple. It is never designed for a long-scale production unless you make a changes of it, right? But it's very lightweight to get started off. Your development can be on this data store out, but when you go to production, you can have the same K0S, but different products that were shown earlier. Yeah. Talos as immutable. So the beauty of Talos is that when you deploy it's a Linux operating system out, you create an image of it and you deploy it, and it's immutable. You cannot change the operating system after you deploy it, right? But you can interact, you can deploy the Kubernetes resources to a kubectl. Yeah, so this is a demo I want to show. I want to show a good scale demo, but I think we'll run out of time. So what I'm going to show you that this is what the typical things will be. We have a cluster deployed out. We will have ingress, traffic ingress deployed out, and then we have adminer. Adminer is a UI of a database, right? You can basically. So the idea test is that you have one adminer pod that is deployed. It has a UI. Within that UI, you give a service name of a Postgres to connect to it. This is a typical test of how can you get a cluster up, right? But otherwise, it's you can always do MicroK8S anyway, okay? And they obviously have a mount here. Let's see, my Postgres I think is not there, so but let's check. I had all the setup out, but I think they lost this. Yeah, I think. Okay. Yeah, the problem that I have is. I seem to have lost this note. I think we need to stop the demo. I don't think. Yeah, I mean, I have this server out. I think it's crashed out somewhere. Oh, no, it's not local. But we still have time, or we can go with next session out. Yeah, I'll just fix up that. Okay. Otherwise, we'll just leave it out. That's okay. It's about installing micro-K8S. That's fine. Yeah. Any questions? Sorry, demo. I had this set up out all the time that we have, but I don't know why the server crashed out and is not connecting out. So, any questions?
We don't have a way to set up the cluster from scratch. I want to have a setup. Say, for example, I want to start my own nodes, set up etcd, all the API servers, routing, kubelet, everything set up.
Yeah, if just run, and that's all I wanted to show it up. If it's possible, I'll just do a quick 5 minutes after the session out. The idea is that you run one command, micro-K8S. In fact, I'll just show you. Yeah, you run just this command out. It will install your control plane and the data plane at one shot. And you directly get a kubectl of it, right? And if you have a more control approach to do that, if you want more, because I said K3S should not have too much of, the defaults are not really good, right? This is how you can change the default out. You can remove the backend and install traffic or install Cilium and all that different things out. So all these are configurations out. But what this K3S claim is that with the original URL, all you have is k3s.io. You can just note it down, right? So the original, when you install this, they actually claim 30 seconds deployment if you have a very good download speed, right? 30-second deployment. The same thing for micro-K8S. All these are single node. You can always have multiple node. I'm going to start with single node, and you can always do multiple node as well. Yeah, this is the command that you install. As simple as that. You can remove the channel because you can always default will be the latest one. That's what you do, and this will install entire thing. You have the kubectl directly, so you get the kubectl directly here. Yeah, same thing for K0s. Yeah, these ones. You just install this, and then there are 3 commands that we have. Actually, have this command. Yeah. So you install that. You start the K3S controller, and then it's all starters. So you can install the control plane and this thing, and you get the keys. And that's what I wanted to show you. I wanted to see better how far that take. But this is all about it. You get the control plane and the data plane together. Yeah, you had a question.
Yeah. So I mean, you mentioned about K3S and all this. These are all light versions. Okay. I mean, in the production grade, I was talk about RK2, which is Rancher Kubernetes NG2, which is having a FIPS coupline. So if any financial institute wants to really have open source, which is open source actually, RK2 would have been a much more benefit. It has all those FIPS compliant, FIPS 140,
True.
DCS compliant, all those things are there. And none of this will be providing whatever you currently show, because those are all lightweight. So why not RK2?
Okay, RKE2, the idea is that if you want to run locally, and if you stay around, I can probably show it to you. The moment it installed the Rancher specifically, installs a lot of components you actually don't need in a local development.
Like filtered out whatever you don't want.
Yeah, so idea is that you need to remove it if you want to add it, right? So RK is on the RKE at the background, it's still K3S. Yeah, RK, so entire Rancher scale RKE at the core of it, it is K3S. It is just deployed with multiple other things to make it one. RKE is background rancher engine. K3S internally, it's the same thing. Okay.
K3S is specifically used for a very lightweight deployment. Like, let's say you want to deploy on edge, you have a lot of devices running on the edge. That's where you use K3S. Because production scenarios can be different, right? It does not have to be a production scenario where you run web applications and AI workloads, right? You can actually run a very small pod, but that can run very near to the edge where the customer actually is, right? That's where you use K3S. And RKE2, as you mentioned, is full-fledged open source Kubernetes.
Yeah, I have a different opinion because K3S and micro K8S are deployed in production. Hundreds of nodes.
Where they are deployed? Yeah, because see, deploying open source Kubernetes is not just like deploying. When any organization wants to go live, there are a lot of compliance regulatory comes in picture. Like let's say in Singapore, if you want to go for MS regulatory comes in picture, whether all those hardening are you able to do it or not in production. There, staging you can play around. And in terms of open source, what we found out is RKE2 is the only currently giving you that flexibility, like open source with a lot of compliance.
For government ones, it's fine. But if you're even for normal business and you want to deploy it, right, they have the compliance out. The idea is that you can install those separate software separately and you can get security hardens one. So if you go to micro K8S, when you go to production, you have to take the support out. And what they do is that they implore all that FIP support and all that, they deploy it out. And micro K8S has been, if you go to Canonical website and all that, it's completely production. So even K3S, they have deployed that. Yes, they don't say that you deployed in government one because the RKE is much more hardened about it. But on a regular basis, I've seen micro K8S being deployed out majorly. K0S, people don't deploy it because Mirantes does not provide. The only reason K3S, K0S will not deploy it out because Mirantes don't support really out. Yeah, but what is the bad side about K3S is that default you cannot go to production. You have to, the moment you install K3S, if you want to go to production out, you have to install Cilium, Calico and all that. Because once you install that, your network layer, anything that is already secure from the Cilium side. And in Cilium, you install some protocols, which is at the eBPF layer, right? So people can't even hack it. Yeah, so that's a point. So sometimes it's a selling point about RK has a good selling point out. My microscale has been very good this one. And Canonical actually does a production support for it. It's quite expensive. Anything else? So my last takeaway point is that the way you wanted to run your, you want to start off, right? My suggestion would be get even a Raspberry Pi. A K3S or micro K8S will learn single node cluster, right? If you have multiple this thing out, you can run it out. Or you go to, Oracle. Oracle supports free Ampere instance, 24 GB RAM, 200 GB disk out, free of cost, forever. And you can deploy the cluster there, your own cluster. You get an instance. I'm telling you, there's no barrier to it. You don't want to, because your local laptop is probably not powerful enough and you have a Windows, you typically need a Linux system to install it and you don't want to install VM there. There's a way to get started off. And then you deploy the simple one that I talked about, the adminer and the database to get started off. And then you can invent whatever things out. And you want to progress further, I would suggest that one good motivation for everybody is that if you want to do all home automation out, have everybody heard of Home Assistant? It's a wonderful software, right? You can try that. It's not a cloud native, but it's it will give you encouragement that, hey, I want to manage my home, the entire home network out. With Home Assistant, you can manage the entire stuff. I'll just show you one last one and then we can finish. It's one of the top ranking GitOps projects. So this, yeah. So this is, you have this thing out. So you deploy this as in your server. It can be Kubernetes server. It can be a simple Docker thing. The reason I say you can deploy into Kubernetes server is because this itself is not enough. You need to have, if you want to take a backup, you need to have a database there. If you want to have MQTT, because all this, most of the different devices can talk to this thing, and you have a Zigbee controller and all that. So that Kubernetes is a great environment. You can have that as services out. In fact, you can have two different, let's say your home, your friend's home, you can control it through a Kubernetes by having the two different clusters in the service mesh. So that's a more advanced case, but I'm trying to, if you start off, you'll start getting ideas. This home assistant is a beautiful one, and it's one of the, you can automate your home, and that will give you a kind of a motivation to, continuously working on it. What can I do better? Yeah, but this itself is not a Kubernetes scale out, but I want to try this thing, these two. Sorry for the demo. I thought we can do that. In case if you have time, we'll just set it up. Yeah.
No problem. No problem. Thank you so much. Now we invite Vishnu. Thank you, Manju.
Thanks.
Okay, so now we'll start with Vishnu on a quick talk on K9S.
Hello.
Hello. Yep. I hope I'm audible. Let me share my screen. You don't have to turn the mic for this one, right? No.
Vishnu, can you test your mic?
Hello. Am I audible? Yep. So just a disclaimer, someone else was supposed to be here and presenting, but they were not able to join. So it was a quick demo or a very quick presentation that I came up with for a tool that I usually use almost every day in my work. And yeah, it will be very quick session, sort of a lightning talk. And it will be very interactive. So just feel free to ask questions. If I fumble or if I do some commands wrong, just let me know. Okay, so I'll just start the presentation. All right, so my name is Vishnu, and I'm a platform lead. I'm also a HashiCorp ambassador for this year, and you can connect with me on LinkedIn using the QR code if you want to. Just wait for 2 minutes. All right, so again, going back to the same question, how many of you have already used K9S, or you use K9S every day? Every day? Damn. I have got a fanboy at least here. Anyone else? Or at least know about it? Oh, nice. That's a good audience then. Okay. Okay. So K9S is basically a tool which you can deploy it on your Linux local machine, Windows machine, even Mac, and you can directly interact with your Kubernetes clusters. You can manage your Kubernetes clusters in a much faster way, and according to me, the better way of running your kubectl commands. So probably if you're using Kubernetes, of course, you must be using a lot of kubectl commands like get pods, describe pods, even logs, and then exec inside the pods to run some commands. So it's just like too many commands, and then you have to keep writing kubectl. So usually you come up with the aliases, right? Instead of kubectl, you write k, like k get pods, but you still have to write describe and all those things. So what K9S is it's a tool. You just install it in your local machine and just type K9S, and it will basically take the kube config that is already configured in your terminal, and then rest is magic. Let's just see. Yeah, just this, these are the slides. All right, so this is my local machine, and just to show you, I already have a local Minikube running. Sorry, Manju. So I have a local Minikube running, and can run kubectl commands like this. And if you already installed K9S, you just enter K9S and press enter. So how it starts is it will show you this nice dashboard. When you open it, you will see a lot of pods running that you already have. Very beautiful UI, and you directly see a lot of important things that you usually don't see when you run kubectl get pods also, right? Like for example, you see CPU and memory percentage and CPU memory usage for each of the pods. For this, you have to have a metric server running. So I already have a metric server running. So you will instantly see the CPU and memory. And also you see the node where it is running. So you don't have to write -o wide every time when you want to know your pod is running on which node, right? So this is the very first basic landing page. When you open a K9S, you will see this. So what you do is how you navigate this. So the way you navigate is you just press Shift : you'll see a small sort of a search bar. You will see a search bar, and then you write your commands there. Like for example, if I write deploy, press enter, you'll see all the deployments that I have nicely lined up. And similarly, if I type services, you'll see all the services right here. So basically just have to do Shift : and then type of whichever resource you want to open. Even the custom resources, if you have deployed, like let's say you have deployed Vault. Vault maybe comes with more custom resources. So you can even write your custom resources here, and it will show you all the custom resources. Just like doing kubectl get custom resources, you'll see all your custom resources as well. So with that, if I go back to pods, now you see there are all the pods that are there. Now let's say you want to see only the pods that are running in your default namespace. You just press 1. That's it. I just press 1, and you'll see all the pods that are running in default namespace. Why? Because it has a shortcut on the top. You'll see if you press 0, it'll show you pods for all the namespaces. And if you press 1, you will see the pods only deployed in the default namespace, right? Now you can do a lot more. So now next thing that you usually do a lot is basically describe your pod or deployments, YAML, anything, right? So here, let's say I want to just describe this Nginx pod. What I'll simply do is I'll just press D. Just pressing D, you'll see the whole description of the pod right there. So this is the kubectl describe command, which you usually do, and you'll see everything that a kubectl describe command will show, right? Now, let's say I want to describe, but I want to see the YAML, right? When you do, sorry? Yes, you have to press escape to come out, sorry. You have to press escape to come out. If I press D, you just press escape, you go back to the previous screen. Yeah, it's almost like Vim. So you press colon and then whatever you want to run. So I was talking about describe, right? So once, next thing you can do is you can check the YAML of any pod. So how you do in kubectl is kubectl get pods -o YAML, right? So instead of that, you can just press Y. That's the whole YAML for a pod, right? So if again I press escape, I want to go to deployment, one deployment. I want to see the YAML, press Y, my YAML. Awesome. I go back. I want to edit this deployment. What you do? kubectl edit deployment name -n namespace. Just press E. That's all. Yeah, just press E. This is your YAML. I'll just make it as 3. And then it's just Vim. You save it, press enter. You see, it's creating one more pod. Pod is deployed. If I press enter on a deployment, it will show me all the pods. I didn't even have to type the pods. I already have a deployment. I'll just press enter. It will show you all the pods by default, right? Now, let's say I want to check like if this pod is related to which owner. So if you know Kubernetes, your pods are like most of the resources have some owners. So your owner of your pod is replica sets, and the owner of replica set is your deployment, right? So from here, if I press Shift plus J, it took me to the replica sets. So it's sort of a hierarchy. It is maintaining the hierarchy, right? And if I press again Shift J here, it will take me to the deployment that it is related to, right? So it follows the hierarchy. It knows the hierarchy. If you open any child and press Shift J, it will take you to the owner of it, right? Okay, now I'll go back to the pods. So we can describe the pod, edit the pod, see the YAMLs. What else? Yeah. Now what we usually do is we check the logs of the pods, right? Of the containers running. So currently I have only one container running on each pod. But if you have more container running on each pod, you just go to the pod, you press enter, you'll see all the containers that are running on that pod, right? So currently I have only one, so you see only one. And if you press enter again, you'll see all the logs, right? So checking the logs is no more kubectl logs, then name of the pod, and then hyphen and namespace and all these things. You can just open this, press enter twice, you're directly in the logs, right? You can see the logs here. Now, one more thing that you usually do is we troubleshoot by logging into the pod a lot of times, right? We have some issues, we want to get inside the pod and run some commands, anything, right? So what usually we can do is once I'm on the pod, I'll just press S and directly inside the shell. So now whatever commands that I'll run will be ran inside the pod that I've just selected, right? So if I just run anything here, will be should I say, who am I? Anyway, I don't know what else to type. Host name, yeah, technically. Anyway, so yeah, basically I'm inside the pod. Now to come out, you have to press exit instead of escape because I'm now inside of the shell, right? So I'll just press escape. So I'll come back to the same home screen, which is your pod. Sorry? Yeah, exit. Okay. So now I've told you like if you press Shift colon, you have this bar where you can type anything. Now if I, instead of Shift colon, no, not this, instead of Shift colon, I just press slash, just one forward slash. It'll again open this bar, but this time it is for filters. Like let's say you're seeing a lot of pods and I just want to filter which of them starts with TMP, and it'll basically filter by name. You can filter by a lot of other parameters, which currently I don't know the commands, but yeah, you can do that. You can filter by maybe restarts. If there are pods that have restarted more than 10 times, you can create regex for them and then actually write a filter, and then it will show you only those pods that have restarted more than 10 times, right? So now exec you have done. So one more thing that you can do is, so now for this Nginx deployment, I already have a service running, right? So now as you see, this is a cluster IP, like all the services are running inside the Minikubes, and Minikube usually runs on a local small Linux VM. So if I can't directly run localhost and it will show me the Nginx page, right? You'll have to do some sort of port forwarding. So in Kubernetes, you do kubectl port forward, the name of the service, and some local port that is open for you, right? So here what you can do is you can simply type Shift J, not J, sorry, Shift F. Yep, you can do Shift F and it will ask you, you want to, which container port you want to expose and which local port you want to expose. So let's say I'll just expose 8005 on localhost and press OK. So it'll show you the port has been activated. And if I do localhost 5, Nginx, right? So instead of running the whole big kubectl port forward command, can do this as well, right? It's basically a port forward command. And if I go back and if I go to pods, you'll now see that port forward is active. So there is a small F that symbolizes that, okay, the port forwarding is active for this particular pod, right? So this one, if you can see here, right? And you can actually stop it. So to stop it, first you have to see how many port forwardings are there. So just press F. It'll show you all the port forwards for this particular service, right? And then you can actually delete this port forwarding. So how you delete in this UI is basically you just do Control D on my Mac. Maybe Windows is Command D or something else. Yeah, Control D. So you do this and you can delete this port forward. Yeah. Once you delete the port forward, is no more exposed, right? Similarly, if you go back, you want to delete a pod, you just do Control D, delete. Yeah. So one more will come up, of course, and you also have an options to do a force delete in case if you need it. Yep. So sorry. So this is how you do these operations. Let me just quickly check if anything is missing. Port forward logs, yeah, RBAC. I'll show you RBAC. So to see RBAC, you have to do just 2 minutes. Yeah, you have to see a lot of YAMLs, right? Like which roles is connected to which cluster role binding, and then you have to mix and match like how it has been done. Here, if I simply go to, let's say, role, all the roles. Okay, I press 0 so I can see all the roles. Earlier it was only showing the default namespace. So here, these are all the roles that usually have. Now, if I open any of the role, for example, the cluster provisioner and press enter, you will automatically see like what access this role has, right? You can easily see that what it can get, list, watch, create, update. This is how usually you write your RBAC in Kubernetes, right? It will automatically show you the resources that it has access to and on what level, right? So for all the resources, I can see in one nice snapshot that what access does my role have, right? And what else? Yeah, just one more thing. Sorry, kubediff is not there yet. Yeah, you just to basically you just have to enter. Sorry, yeah. Yes, yes. So what I usually do is, let's say I have a kube config that has 3 contexts, right? So I can usually write K9S space -- context, which context you want to point to. So I will open 2 terminal or 3 terminals. You have 3 clusters, 3 different contexts. Just enter K9S space -- the name of the context, press enter. So that shell will be dedicated to, or that whole K9S session will be dedicated to that context. On the other terminal, you can also run the same command, but with a different context name. So yeah, that shell will be dedicated to that one. Yes, it's only one cluster. So at one time, it will only view one cluster. Yes. No. Tmux is basically you can change the sessions internally in the Linux terminals, but as a binary, it's just like kubectl. Once you run a kubectl command, it will run only for one cluster at a time, right? Similarly, it is running the kubectl commands. Basically, it's hitting your kube API, but yeah, regularly so that you can see these resources in a nice way.
But in any of the tools, you would have only one time, right? At one time, you can see only one cluster. That's also good for security because you don't know which context.
Yes, this is.
So you can use Lens, as I told you, there's something called Cube Browser, but you have to select those clusters individually. At one time, you only work on the same. If you want to see pods of multiple clusters at one shot, I don't think that's the same.
Because there you have a UI, you select the cluster and you will see all the resources for the same. I mean, I'm not sure if you can have if you have a tool, sorry, if you have a tool where you see all the resources for all the clusters at once. I'm not sure if we have it yet.
Just drawing some knowledge of Kubernetes. Kubernetes has something of Visual Central. It will view actually a single plane which all clusters as say it's Kubernetes.
Oh, okay.
This,
Sorry, not
you
sure.
can actually use, okay, so I see what you can. There's something called Elastic. You know about all Elastic, right? You can get an agent for this thing and all this can be seen. But then you're not managing the cluster directly with Elastic. So you're only viewing it. Yeah, that can be done. But otherwise, there's a lens, open lens that we're talking about. And there's something called headlamp, which is very good. But if you're a keyboard warrior, this is the best.
Yep. And one more command I just wanted to show you is that just type pulse, P-U-L-S-E, and if you do enter, you'll see this sort of a big dashboard. Sorry, where you see all the resources in one glance, like how many pods are running, how many replica sets are running, and if you have any events that are that have errors in them, just last command. So you can see it like that. And one more small command, just last one, Ritesh. So sorry. Oh, I don't want to enter. I'll do X-ray pod and then namespaces default. Yep. So if I do X-ray, then the name of the Kubernetes resource that I want to look for, and then the namespace, you press enter, you will basically see this sort of a UI. So it will show you all the pods in that namespace along with sort of a tree structure, which you usually use in Linux command. There's a tree command. So this is similar structure. So instead, if you do X-ray for pods, services, then namespace default, you have the service and then the pods that are actually using those services. So sort of a nice UI in a tree structure you get. It's an X-ray feature. That's all. Any questions? All right. Thank you. Thank you. If you have any questions, I'll be right there. Yep. I'm just here if you want to have any questions. I'll be just right here.
No, he's not going. He's one of the organizers. He's not going.
Yeah, I'm organized.
Thank you so much, Vishnu.
No worries.
Vishnu, can you stop the sharing? Okay, perfect. Huh? Where did he get? Okay. Okay, we are almost to the quiz. Someone wants to join Code Cloud subscription, then you have the promo code. You just need to scan this particular QR code. You will get some offer. There is another option. You win the quiz. First 3 will get this subscription free for 6 months. Yes. Okay. So either scan the code or do your best in the quiz. Okay. Next. The Kubernetes Bible by Packet. This is the offered code for this. And again, if you want to win this, you need to come. First 2 will get the Packet hard copy. Total 8 prizes today. Okay. I don't have the OpenAI for now, but then